you ever felt that math is not your friend? If so, make it your friend through practice and writing. Welcome to Hasna Spot Math. Let's spark our math skills together. I welcome you all to learn how to derive the antiderivative using the fundamental theorem of calculus part 2. It's so simple. You have to be very careful on the upper limit. If your upper limit is a variable and it is just x, the things are so similar for you. Replace your function d with the upper limit x and hence you derive the antiderivative. Please pause the video and try to solve these questions. Let me see how many of you are able to solve it. If you look over here, what is the upper limit? Exactly, it is x. So just replace your function t with x. So what will be the answer? Exactly, x square minus 3x plus 2. If you prefer, you can use the normal antiderivative concept like t squared divided by 3 minus 3t squared divided by 2 plus 2t. Substitute x minus substitute 0 so that you'll get the final answer as x square minus 3x plus 2. Now what about the next? Same thing. So you'll get it as, very good, x square minus 3x minus 4. Please try it out. Here a slight change. Hope you have noted down. Your upper limit is not x, it is 2. But you can notice your lower limit is a variable x. Just swap it both. Don't forget to include a negative sign when you swap the limits. So it becomes negative 2 to x sec t dt. As you are swapping, we are including a negative sign. Now what's your upper limit x? Just replace your t with x. You get negative sec x. In this question, be careful. We are just finding the antiderivative. We are not deriving the antiderivative. We need just the antiderivative. So if you simplify, your lower limit will be 0, your upper limit will be t. And you get e power x over 2 and you are squaring it. When you square it, it's nothing but you multiply with the power. So your 2's get cancelled and by default you have a dx here. So when you are integrating, it's nothing but e power x. Apply the upper limit, which is nothing but t, and apply the lower limit, which is nothing but 0. And you get e power t minus e power 0. Anything power 0 is 1, and so your final answer is exactly e power t minus 1. Let's proceed with the next question. Here if you notice, it is nothing but sine square x plus cos square x dx. Hope you all remember the identity. Sine square x plus cos square x. Exactly, it's 1. So actually we are finding the antiderivative of just dx, which is x. And don't forget, the lower limit is 0 and the upper limit is t. So the answer will be t minus 0, which is t. Let's dive into finding the derivative of antiderivative in case if your upper limit is a function with respect to x. So if you notice here, you can see the upper limit as x square. So what's the rule? First, you're supposed to derive the upper limit, which will be 2x, and then multiply with the function where you will replace your t with x square. So here we go. X square is nothing but 2x, and you will replace your t with x square. So you will get 2x times e power minus x power 4 plus 1. In this particular question, if you notice, your upper interval and the lower interval are variables of x. So how will you do about it? We will first derive the upper limit, which will be -1. Once you get the derivative, replace your t with your upper limit. So you get sine. In the place of t, please substitute 2 minus x square minus, what about the lower limit, which is nothing but e power x. When you derive the lower limit, you get it as e power x. Now replace your t with e power x. So you get sine e power x the whole square. If you would, you can simplify to the simplest form, or else you can proceed like this. Now, if you need, you can split this interval using any number. Let's prefer 0. So you get e power x to 0 and then 0 to 2 minus x. If you notice, your upper limit should be a variable. But what about the first case? So let's swap it. When you are swapping, don't forget to include a negative sign. Now as we did, you can proceed with the upper limit derivative, which is e power x itself, and then replace the value of t with e power x. Similarly, the second half. So your final answer will be as we found in the beginning. Negative sine 2 minus x the whole square minus e power x sine e power x the whole square. Or else you can rearrange it like this. Let's try it out this question. Same rule since you are finding the derivative of the antiderivative. What is the upper limit derivation? You will use the product rule. X, that is your u, dv, which is same as e power x plus e power x, and your derivative of x is 1. So you get it as e power x, which is common. If you want, you can take it outside, times x plus 1, and in the place of t you will replace by x e power x. So you get e power 2x e power x minus, let's find the derivative of 2 minus x, which is -1. Already you have a negative sign, so let it make it positive. Now replace your t with 2 minus x. So you get e power 2 times 2 minus x. So here we go. Here also we can split it using 0. As you are swapping the first half, you get 0 to 2 minus x. And now let's derive the limits and then replace your t with the corresponding limits. So your final answer is e power 4 minus 2x plus e power 2x e power x times e power x plus e power x x. So simplest form can be rewritten like this. That's all for today. See you soon. Until then, keep revising, keep practicing. Wish you all the best. Bye-bye.